Again, good evening, and welcome to Kopernik Observatory. My name is Drew Desker. I'm the director here. It's great to have a full house. We also want to welcome those watching on our live stream, and just I'd like everybody here in the house to wave to everybody on the live stream. So if you would just do that. There we go. There we go. Great to have you with us. We are really glad to be able to be open again and do what we do. Now, just as a matter of interest, who's here for the first time? Wow, great, great. Okay, now who here is a member of Kopernik? All right, a reasonable number, So the people who raised their hand second know something very valuable, and that's the value of a Kopernik membership. So we are a nonprofit, 501c3. We squeeze every penny out of every penny that comes in. But ultimately, if you like this kind of a place, this is a Kopernik membership is actually a great value. For $60, a family can have a Kopernik membership for a year, and you can get into over 350 other science centers. We belong to what's called the ASTC, Association of Science and Technology Centers. And your Kopernik cards get you into every one of those. So you could go to Roberson. You could go to Ithaca Science Museum, Science Center. In the golf course. Oh, I think the Ithaca Science Center has a little golf course. Yeah, you could go there for free. Then you could go down to Enthusiasm. I love it. I love it. That's great. That's great. It's fine. The Franklin Institute down in Philly, or the Intrepid down in New York City. So if you like this kind of place, and they're in a position to support us, it would be great to have you as one of our members. Every Friday night we do this from March to mid-December, and it's an opportunity to learn about something new. Tonight's program is about fall skies, but it's not always about astronomy. Actually, in a couple of weeks, actually in November, we'll have a meteorologist from the National Weather Service here in Binghamton that'll talk about, do you remember that huge snowstorm we had back in 2020 where we had 40 inches? Well, they're going to talk about that and how that happened. And yeah, we had a snowstorm that was probably as tall as you were, actually. It was really tall, exactly. So anyway, but one of the things we discovered, well, back in March of 2020, we had to shut down because of COVID. And he said, all right, well, we'll wait a couple of weeks until this whole thing blows over. Well, that didn't exactly happen. So we decided we still wanted to stay engaged with the public, and so we started live streaming. And we have now been live streaming for basically over 2 years. We now have over nearly 11,000 people on our subscribe to our YouTube channel. Back in May, Jeremy Carty, who's sitting behind the screen here, is our live stream astronomer, and he did a live stream of the eclipse in May. Did anybody see that? The eclipse in so it was a Sunday to Monday, and at one point we had over 25,000 people on our YouTube channel. The chat on the side was flying by like a CVS receipt. It was extraordinary. In fact, actually some people, and I'm not throwing any shade at NASA whatsoever, but some people actually commented that they switched from NASA's live stream to our live stream because they liked ours better. So, in fact, actually tomorrow we will be doing a live stream of the Artemis launch. So Artemis, if you remember your Greek mythology, Roman mythology? Your mythology, your mythology is the twin sister of Apollo, and so the Artemis is the missions that will now be returning us back to the moon. So they're doing an uncrewed mission to the moon that was supposed to be launching tomorrow. So I believe at 1 o'clock, Jeremy will be here and start a live stream for that, and then we will sort of fold in NASA's live stream, but have add our own little commentary, and it's been a lot of fun actually watching the comments coming in from various people. So again, every Friday night we do this, and then if it's clear, like this like it is tonight, we invite you to come out afterwards. My rule here is, if you first come to Kopernik and you cannot leave until you look through a telescope. So I'll need your keys. So anyway, we'll have the moon, Jupiter and Saturn will be up, and we'll see what other things we can find. If you stay a little late, we may even be able to see the Milky Way. Well, I'm very happy to be able to introduce our next speaker. Roy Williams, who is one of our Kopernik educator, has been here longer than I have. He likes to make an entrance, apparently. Yeah, more cowbell. Anyway, so Roy's been an educator for many years here, and now actually has a full-time job teaching science in middle school and high school, but still spends his summers here and pops back in for programs. So we're glad to have Roy, and I'm going to hand it right over to you.
Okay, thank you. Thank you, Drew. Okay, make sure the level is good. All right. Well, just so you know, if you want to get on our email list, I got a little clipboard here. Just pass it around, and we send out emails once a week or so about what's going on. So if you're interested, you can just pass that around. And I do want to mention we have AstroFest coming up. Our astronomy festival is coming up at the end of the month, September 30th and October 1st. So I got these little cards here, and I'll leave them back here. If you on your way out, if you want to grab a card, we'll leave it right here by the models. Look at these beautiful models here. You got we were just talking about those rocket ships. All right, so make sure you visit us at Kopernik.org, and we got a lot of neat things to show you on the website. Today's program, obviously, and here's AstroFest. So if you want to, we'll be getting a more detailed schedule, an hourly schedule, what's going on. It's a 2-day event, rain or shine. And we're going to have our fall public schedule out very soon. We're just finalizing that. And if you shop on Amazon, which I think most people do, if you sign up for smile.amazon, that will actually give us a donation and no cost to you. So check it out. You just got to make sure you're on have that right login, the smile.amazon. And what else? Oh, at the bottom of our chart is our clear sky chart, clear sky clock. And this is something we use when we're getting close to an event, and blue is good. So it looks like we're going to be clear until about midnight or so. Even then, it's still going to be okay. So I think we're all right. But I tried to get everybody out to see the moon before you got into the program, just in case, because you know how the weather is here. So anyway, check out our website sometime, Kopernik.org, find out what's happening. And then our social media is up in the upper right-hand corner. Okay, so you can hit that. But all right, so let's begin. First, I want to just kind of talk about some of the websites I like to go to. Spaceweather.com is a really good website for the sun. And right now we're heading into a lot of solar activity. It's an 11-year cycle on solar activity, and we're on our way up. So we get these storms called sunspots right here that are on the sun. And these black spots are bigger than the Earth, because you can fit about 110 Earths across the side of the sun there. And so you can imagine how big those sunspots there. So they're magnetic storms that are actually cooler than the rest of the sun. That's why they appear black. So it's kind of like an optical illusion. If you had a sunspot right here, it'd be super bright. But it's about 2,000 degrees cooler, so that's why they appear black. Anyway, Space Weather is a great website for all types of things relating to the sun and the northern lights and things like that. So I highly recommend going to that website. Another website is called heavensabove.com, and now there's a lot of apps that do this. So this shows you where to find the space station. Unfortunately, there's no space station flyovers tonight. So sometimes we try to time it so we go right outside and watch it fly over at the end of a program, or sometimes in the middle of a program, which isn't so convenient, but we do that. But just to give you an idea what it looks like, one of the good passes here, so if you click on the date on September 7th, they're all in the morning right now at like 5 in the morning, so there's nothing going on in the early evening. But this one starts out at about 5:42 and goes across the sky. So they give you a map where to look to see the space station. It's going to look like a bright star as it goes across the sky, moving at 5 miles per second. to give you an idea of how fast it's going. But anyway, yeah, I highly recommend that one too. One pass takes about anywhere from 7 minutes is a pretty long pass, something like that, maybe technically 8 minutes or so. This summer we talked to the space station. Drew just left. He did we actually talked to the space station with our students with a ham radio, and he's involved in that, and they had a really good pass that lasted like 9 or 10 minutes or something. But anyway, all right, so tonight's program, let's look for Artemis tomorrow. What time is that going off, Jeremy?
2-hour window starts at 2:17.
2:17, okay, is the 2-hour window. All right, so pay attention to that. And, all right, here we go. So, fall skies. So, here we go. All right. So what we're going to do is kind of do the ABCs of stargazing, all right? So what you can see in the sky, kind of already talked about the International Space Station, and we're going to talk about solar system objects and also some deep sky objects that you can get to see. And all right, and hopefully we'll get outside and actually do some real observing because it looks like it is going to stay clear, which is fantastic. So A is for angular size and distance. All right, so one of the things you can do is you can use your own hand to figure out how far apart something is in degrees, okay? So one vertical fist is 10 degrees, okay? And I can kind of test that. So 10, 20, 30, 40, 50, 60, 70, 80, 90 degree angle, right? So, all right, did anybody think of the Three Stooges when I was doing that? Okay. Okay. So this one, the Aussie sign, that's a new one to me. But anyway, 15 degrees, whatever. But thumb is 2 degrees. So but you got to hold this out at arm's length. Obviously, if you're close like this, the rule of thumb is that it's held out at arm's length. And we're all proportional, so roughly that's correct. B is for brightness. Now, there's something called a magnitude scale, and it might be opposite of what you might think. There was a Greek guy, Hipparchus, a long time ago, who, as the sun went down, he saw the brighter stars come out, and he called them first-class stars. And then 15 minutes later or so, the second-class stars, and then the third class and fourth class. So the higher the number, the dimmer it is. All right. We can see around 5.5, the human eye, maybe 6 on a really good night. That's the limit of the human eye, all right? And you're getting very faint as you get toward, I think the Hubble telescope is in the 20s or so, what it can see. Not sure what the Webb is, but, and then if you go to the left here, you get to see Vega is one of the brighter stars that are out. You have Sirius, which is the brightest star, then Venus, and then the moon. So you get into negative numbers, which is a little confusing, right? So once he started that scale, it kind of stayed as a tradition. And some people claim it works really well the way the human eye works, because which would be a whole program on that. So we're not going to go into that. But anyway, that's the magnitude scale. So, and the sun is like negative 26. All right. And it's not a linear scale, it's logarithmic. We call it logarithmic. But C is for coordinates. So every star in the sky has a latitude and longitude, just like a location on the Earth. All right? Binghamton, New York is basically somewhere around 76, 42 degrees north, 76 degrees west, roughly. So we have a location on the globe. So what we do is we create a globe around the Earth called the celestial sphere. We got one of those in the back of the room. And the celestial sphere has latitude and longitude projected. Pretend the Earth is a projector, and it's projecting these latitude and longitude lines. We call it something different. We call it right ascension and declination. But it's the same principle. And you can locate any object given these two sets of coordinates. So that's how our computerized telescope. So when you see either our 20-inch telescope or the 14-inch telescope automatically move to an object, it's using these coordinates in the computer to figure out where to go. And so that's real important stuff there. All right. So what can we see in the sky? All right. So there's a variety of different types of objects that we can see. We talked about the International Space Station. I did that so we wouldn't have to toggle to kind of save us on the live stream, so we wouldn't have to deal with going to that website. But yeah, so the space station, here's what it looks like. It's reflecting sunlight. That's why you see it. All right. So it's only around when the sun is going down, or just went down, or when the sun is just about to come up, because it's in that sunlight. So you ever notice, like when you're maybe out west or in the Adirondacks or even around here, right, when the sun is setting, the tops of the hills are still lit? Or you ever see an airplane and it's super bright up in the sky and it's like, wow, is that a UFO? Well, that's what the space station is. It's 200 or 300 miles up, and it's reflecting, it's still hitting the sunlight, even though we're in the dark or in the twilight down here. So that's when we're able to see the space station. So.
I saw a very big light before, a very giant light, like this big of a light.
Yeah. Okay, lights can get really bright. There was a big bright one that came down somewhere. Where was that meteor? Do you know about that meteor that came down? There was someone, I thought it was in New York or something. There was some bright. But, okay. So we'll get to see solar system objects. Tonight you'll get to see, some of you already got to see the moon. And then we'll get to see Saturn and then Jupiter. We suffered through this summer of like a planet drought because they're all up at like 2 in the morning. And the real problem is especially since we move our clocks forward an hour, it doesn't get dark until like 11 o'clock or 10 o'clock or whatever. So it takes forever to get dark. And in the summertime, it's good to have planets out because you're waiting for it to get dark, and they're bright enough to get in. But so that was kind of tough. Now we're kind of heading into the planets. So we got lots of planets that are, over the next couple months, are going to start showing up. And I'll show you using a program called Stellarium why that is. But Venus, the Moon, Saturn, Jupiter, Neptune, and Uranus, okay, are all kind of doable with our telescopes. And some of those are naked eye as well. The Milky Way, you can still see the Milky Way this time of year, but the summer is really the best time to see the Milky Way. But September and October move through. By the way, the main thing about the fall is that the fall is the clearest time of year for our area. Okay, it's a 40% chance of it being clear. All right, which is better than September and October, and then we hit November, and it's really bad. So lots of clouds, and so one of the things we try to get to see is the Andromeda Galaxy. It's not really doing justice to it. It looks better on the monitor, this projector, but it's a little fuzzy patch right here. So that's kind of like what it looks like in the naked eye. That's our building and the tower behind it. I'll show you a close-up picture of that in just a little bit. And the Dumbbell Nebula. So the Dumbbell Nebula, this is a star that's kind of exploded. It's kind of shedded its outer layers of its atmosphere. We also have the Ring Nebula. I'll show you that in a little bit. And it's a similar type of object. And as we get closer toward the winter, we get to see the majestic Orion Nebula, which is in Orion. And it's an incredible cloud of gas. You can see with an 8-inch telescope, 8-inch mirror, you can really start seeing the structure of the gas, even in a 6-inch. And it's about a half a light year across to give you an idea of size. And there's a whole bunch of stars that are forming. This is one of the first things the Hubble Space Telescope looked at. They looked at forming stars inside that nebula and got to see that there's these disks of material around these stars forming planets. So that was one of the first discoveries that Hubble did in 1995. So one of the things we have going on is meteor showers. So there is a meteor shower coming up in November called the Leonid meteor shower, and it appears to come from the constellation Leo. That's why we call it the Leonids. And there's a little bit of a local story about this. But basically what's going on is that the Earth is moving into a debris field left over by a comet. And this happens, it happens every year we run through this debris field. And that's why every November 17th is the Leonid meteor shower. And then in August 12th is the Perseid meteor shower. And then we have other meteor showers on certain dates, because every year we're running into this debris field of different comets. The parent comet is called Comet Tempel-Tuttle, and it was discovered just after the Civil War. And Tuttle was from Marathon, New York. So he was, I think, a veteran of the Civil War, and he had his telescope, and I don't know if it was discovered from Marathon, but I think he lived in Marathon. And it orbits in a 33-year orbit. And it just so happens that every 33 years, it replenishes, it comes by and replenishes the debris field. And not all the comets are that good at doing that. This is the only one I know of that. And so every 33 years, you get something called a meteor storm. And in 2001, I was able to see the meteor storm right here at Kopernik. Did anybody see that in 2001? So, I know. Okay. Okay. All right. So anyway, so what? 2001. So 2034, you're going to get another. It's going to peak in the Middle East, I guess. So we were really lucky here. As it got dark, you're seeing meteors all over the place. Now, typically a meteor shower, if you see one a minute, it's fantastic, right? Okay. We're seeing about five every second. It was just, they were just all over the place. Now they weren't super bright, and it was almost like, am I seeing things? But you weren't. And as it got darker, you could see more. And then we stayed up all night, even in as the twilight started coming from the sun. I swear it was picking up. So if you were in Ohio or a little bit further west, it was probably even better. So it was amazing. So we got some pictures a couple of years prior to that. Again, let me just kind of turn that light off here. Let me see if I can. Is that going to screw things up? So this is this little cloud. This little cloud here is a Leonid meteor that exploded. Two things happened that night. There was one that came in like that and exploded, and it's left this cloud there for about 10 minutes. In fact, we didn't even have the camera ready to go. We ran in the building and set up the camera and took that picture. So it was even brighter in the beginning. And then, I don't know if it was the same year, I think it was a few days later, or maybe it was another year later, we saw a meteor during the Leonids that just went right across the sky. It was something out of a science fiction movie. It looked like a ball, and it was just slowly, it took like 20 seconds or 30 seconds to go across the whole sky. It was amazing. In fact, some guys started yelling in the parking lot, and so I ran around the light wall there and got to see it. So I didn't even see the whole thing, but it was really amazing. I think it just skipped out of the atmosphere. So if you look up enough, you can eventually get to see some really weird things, incredible things. So yeah, comets are fragile. We're going to make a comet right now to kind of show you what is a comet. And comet is made of ice, but it's different types of ice. And here we go. So we're going to need the camera. Is this looking good? Tell me if this is. Yeah, you might need a little more light. So, yeah, that's right. Because we're gonna move the camera. Remember, you got it? Okay. So Jeremy's gonna play cameraman as well as. Oh no, he's got it. So, all right. So our first ingredients is what most of the comet is made out of. It's called dry ice. All right, and it's really cold. It's really cold, so you got to wear these gloves. And it's what is dry ice? Dry ice is carbon dioxide. So you exhale carbon dioxide, and when it's frozen, it freezes at about 110 degrees below zero. So that's why you got to wear the gloves. Otherwise, you get instant frostbite. Okay, it kind of feels like you're burning your hand. So that's what most of a comet is. It also has some water ice. So I just got some liquid water, but when I put it in there, it's going to freeze. Okay. And we're going to chop it up a little bit. And then it also has a little bit of ammonia. Yeah, the stuff you clean your floors with. So that's the main three ices that we have. And so when geologists and astronomers talk about ice, it's in our minds we think water, right? So they're talking about different stuff it's things that are frozen. You got a question? Yeah.
When dry ice is in a liquid form, if you would touch it would
Well, dry ice skips the liquid form. So, see, it goes right from a solid to a gas. Under this pressure, it's never going to hit liquid phase, okay? So, like, you can't melt it and swim in it, right? It's not going to work. So, it's okay. So, Okay, so what is dry ice used for? Anybody know? What kind of use it for?
No.
So in an emergency situation, you lose your freezer, you can use dry ice. My family used to, my grandfather was a cattle rancher. We used to go down to Tennessee, and as a kid, I'd be in the back of the station wagon with a steer all packed up, and packed into that paper stuff, with tons of dry ice, and I'd be freezing in the back. And so that was my first experience with dry ice. Anyway, also comets have rocky material, so we've got some rocks here, and we'll also use some cat litter to be our rocky material, and maybe a dash more of. There we go. Okay, here we go. Let's make our dirty snowball, because that's what a comet really is. Okay, I gotta remember I'm on the internet too. I gotta face the camera. Life is just so complicated now. Okay, here we go. I need more water. I think it's not. Okay, let's do a little bit more. Here we go. All right. Let's see what it looks like. Ooh. Notice it's falling apart, right? So yeah, comets are very fragile. This comet Swan here broke up into a whole bunch of pieces. Anyway, most of the time comets are super far away from the sun, so nothing's happening. But when they get close to the sun, energy from the sun hits the comet, and you get an atmosphere around the comet, and you get a tail. So that's what a comet is. So you can see some rocky material, and you see the whiter areas. And when we send spacecraft to some of the comets, this is pretty much what it looks like. So this is called the nucleus. Now, to give you an idea of the size of the comets, the nucleus is typically a few miles across. Comet Hale-Bopp, any adults see a Comet Hale-Bopp 20-something years ago? Yeah, that was about 40 miles across. That was one of the bigger comets we've seen. And anyway, so like Halley's Comet is about 6 miles across. So I'm not sure the size of the one that causes the Leonids, but it comes back every 33 years, and see all this stuff that fell on the floor? That's the debris field that's leaving, and then the Earth is running into it every 33 years when it gets replenished. So any questions on comets? Yeah, what do you got?
I have a question on that. What is that? What?
That is the space shuttle. It was an airplane that went into space. So we're moving on to new stuff. That's before your time. Okay.
Some are periodic, which means they come back, and some aren't.
Yeah. Okay. Good point.
They come from what the Earth.
Yeah. Right.
The type of
Right. So the question is, where do comets come from? Comets, some are periodic, where what we're talking about, they're short period, under 200 years. Halley's Comet is 76 years. Hale-Bopp is about a 4,000-year orbit. And then there's some that they come in and they leave and they never come back. Okay, those are open orbits, so to speak. So they come from what we think is called the Oort cloud. And the Oort cloud is this halo of material, really far away from the sun. So, yep, you ready?
The question coming in.
Oh, okay, sure.
Jeremy.
Go ahead.
So it's related to comets and meteor showers. Is that material that's replenishing for the meteor showers, is that coming from the comet itself, or is it material pulled by gravity from the comet?
Yeah, it's the comet falling apart. So what we're talking about, the material, what is the material? It's a combination of ice and rocky material that the comet is dropping off. And the Earth is going to slam into it. So it's just floating in space, minding its own business. And every 33 years, this comet comes in and drops more material. Now, it takes a while sometimes for that material to drift into the right place for the Earth to hit it, too. So there's actually quite a lot of, physics that goes along and factors, solar wind, different gravity from different planets, for them to really predict where on the Earth the storm is going to be. They're predicting it's going to be in Israel, the Middle East, in the next storm. So we were really lucky, because I never realized how short. It's a very short window. So just maybe 12 hours or something when you see that storm. So, okay, did that answer the question there online? Anything else? Okay. How many people we got online watching?
30 viewers.
Wow, not bad. Okay. All right. So
I'm a viewer too.
That's right, but you're here. You're real. Okay. All right. So, all right. I think that's pretty much it. Let me just let me see what we got here. How would oh, some tools you can use. Okay. So, oh, stellarium. Yeah, that's right. So I'm going to show you stellarium. So we're going to need all the lights out. So if hey Drew, can you get the lights out, because we're going to show stellarium. And good job. And we need more camera people, or we need automatic cameras, like some of the guys on the internet. So yeah, there's all different types. Jeremy knows more about this stuff than I do. All the different stuff that you can use. I see people out here with their phones. Many of you are already aware of these apps and things. That's totally cheating. No, it's okay. Just, if they have a question afterwards. So I'm just joking. Anyway, so what I like to do is I'll go out with my laser pointer after the program, and I'll point out some constellations and try to learn them that way. And then what you do is you try to learn. I mean, their phone's fine. But I think it's good to have someone point it out to you, and then you get a star map, and then you try to find the constellation with the map. But maybe the phone's better. I don't know. And I'm a anti-technology when it comes to that. So, oh yeah, that was what did you do here? That was your. Is that your? How do I go back? I can't see now. No, hold on, I got it. So is that your picture with using a cell phone? Yes. Of the moon? Okay, so Jeremy's really good at this stuff. So both of these are from using his smartphone. So he's the guy to talk to after the program if you want to talk to about that. So yeah, hopefully clear skies. So let's go to stellarium. Now, Stellarium is a free program. If you go to stellarium.org, it's a really great program to use, very user-friendly. Let's see. I'm gonna reopen it live, so it opens up on what time it is if you have your location set, right? And then let's just run through what it's going to look like tonight. So here we are live, all right? And so there's really 3 buttons I'll show off in the beginning. So right down here, there's 2 nav bars that come out, this one on the side and this one at the bottom. And then the first one gives you the lines of the constellations and then the names, all right? And then you can see the drawings, okay? And then using the wheel on your mouse, you can bring it back so you can kind of see more of the sky. It has the cardinal directions. I'm looking due south. That's S for south. And you got southwest and you got southeast here. So I'll take off the pictures just for a moment. And then you got so what you want to look for right away, if you didn't get to see the moon, whatever telescope we have the moon in, make sure you go to the moon first because it's getting low. We're probably still okay for a little while. I'm almost done. But you hit the space bar and you can zoom in. And you can see it's a half moon, or what we call first quarter, which means it's 1/4 of the way around its orbit on its 28-day, 29-day orbit. Okay, and so first quarter moon. So it's going to be setting pretty soon. And then in terms of other objects, you can click on the thing that says planets here, and it'll turn on the planets. All right, and then we have Saturn right here. So you click on Saturn. So Saturn is in Capricorn, and you click on that, and then zoom in. You can see what Saturn looks like. Now, you see these moons around Saturn as well. So when you look through the telescope tonight, try to find these moons. You got Dione, you got Tethys, Enceladus, you got Rhea. So you can see about 7 moons of Saturn. All right. Now keep in mind that you're thinking these are going to look like small disks or stars. They might be flipped depending upon the telescope. So when you look at it, don't think that it might be flipped 180 degrees. They might be up here. Okay, so keep that in mind. What you should also look for in Saturn is this division between the rings called the Cassini division. So look for that. If the atmosphere is really steady and with a good telescope, you can see the Cassini division. Okay, all right. Yeah, what's your question? Go ahead.
What is that line? How?
This line right here.
No, the other line, the line of the thing that.
Oh, the Cassini division. So there's a blank spot in Saturn's rings. It just so happens that there's a gap. In fact, when we sent the Voyager spacecrafts, we send them through that gap because there's relatively very, very little material. By the way, the rings of Saturn, most of the rings are only about a football field thick. To give it, most of the material, like 99% of the material, is just about 100 meters thick. So it's really thin. Talk about the rare occurrences. Once in a while, the rings get exactly edge on, and in the 90s, I actually saw the rings disappear for about a week. It was a straight like pencil line, and then it disappeared for about a week. Actually, it was about for a month. You saw it as a pencil line, and then for a week, it totally disappeared. You could see no rings, which was really weird, and that won't happen again for a long time. So, all right, I'm almost through, and you can ask more questions too. But Jupiter is the other object we're going to get to see. Now, Jupiter is just rising right now. Look at this. It's right on the horizon. What are the odds that it's just right there? So you won't see it because we got trees in the way. So if you go out right now, we won't have Jupiter in. We should be able to get the Moon and Saturn in, okay? So you have to wait. Well, how far do you have to wait? Well, you go over here to the clock, and then you can see. Now, if we chop down all the trees, then you know, or if you had a laser that goes, right? Then maybe you'd see it. But so anyway, let's go with 1 hour in advance. So actually, maybe that says 8:30. Maybe, I don't know. Maybe it booted up in the wrong time. So maybe it is higher than I think. So anyway, at some point, I'm just telling you the rule of thumb is that when it hits that horizon, it takes about another hour before you can see it. Maybe you can get lucky, half an hour, depending upon if there's a hole, where you put your telescope out in the yard. But you got to give it some time to get up high. So we'll probably be seeing Jupiter around, I don't know, 9 or 10 o'clock. So I haven't observed in a little while, so I'm a little rusty on when exactly it comes up from this location. But anyway, that's pretty much what you got. Now, in terms of deep sky objects, let's see. In this program, hopefully this is the one that doesn't have the deep sky objects, Jeremy? There's one of these software that doesn't have the deep sky. Okay. So I have to turn it on in the toolbar. So here we go. Oh, there it is. Okay, Ring Nebula. Boom. You have one of these. Anyway, this is the location of the Ring Nebula. Oh, good, it's there. Yeah, so this is that like the dumbbell nebula. This is the same type of object, but we're looking at it from top down, and you can see the star in the center that it's exploded, and it's shed this ring, okay? And this ring is still expanding. This is called the Ring Nebula. And anyway, that's a key object to get in because it's fairly high up in the sky right now. Okay, so it's near the bright star Vega. By the way, one of the things I'm going to point out is the summer triangle. Vega, Deneb, and Altair make this summer triangle. So that'll probably be one of the first things I point out when we go out there with the laser. Now, by the way, if you see these red lines here, I don't know if you can see it. Some of you probably can. Each constellation kind of has like a boundary, like a state on what we. I'm going to turn that off. That's kind of, where is that button? But anyway, just so you know that. Not sure where that button is. But okay, let's look at the M13 globular star clusters right about here in Hercules. And if you zoom up there, oh, I almost nailed it. Boom. It's just off by a little bit. And here it is. So this is a big ball of stars. It's about 500,000 stars all in a ball. It's called the globular star cluster. It looks like a glob. Okay? And in the beginning, a lot of, like when in the 1700s, 1800s, the telescopes weren't that good. So a lot of people thought that there were comets. And there was a comet hunter named Messier who plotted these objects because he didn't want to be fooled. He was looking for comets. So this is the 13th object that he plotted on a star map that he categorized, or cataloged, I should say. So it's called M13, all right? Now, the Andromeda Galaxy is the reverse of that, is M31. And that's in Andromeda here. So you can also, if you can hit the this button over here, F3, or you hit the magnifying glass and you type in M31 or Andromeda, I think will do it. Did that work? Maybe not. Let's see. Okay, here we go. Hit enter. No? Did I have to hit Andromeda? Andromeda. There we go. Oh, here we go. So it brought me to the constellation Andromeda, which is right here. But right here is the Andromeda Galaxy. Now this object actually is better in smaller telescopes. It's 5 full moons across. So if you look at it through our 14-inch telescope, you're going to see the structure here in the, you'll see the bands, or the spiral arms. But like right here, you see right here, you'll see that in the 14-inch. But when you look with either a pair of binoculars, even on tripod, and some of the smaller telescopes, you can see the whole thing. And what you want to do is, don't look directly at it. What you want to do is look off to the side, a little bit off to the side, and it will just kind of jump out at you. That's because you're using part of your eyes that called the cones that is sensitive to low light level. So same thing when you're looking at it naked eye. Like I'm going to hopefully point it out to you. Well, we got the moon out, so I'm not promising it because the glare from the moon. But if you look off to the side, you'll see this little fuzzy object. So this is the furthest object you can see with the naked eye, and it's 2.4 million light years away. So you're looking at something that light left before the ice ages. Okay, so over 2 million years ago. So, all right, that's pretty much it. So I highly recommend using Stellarium. Yeah, perfect. And what I'd like to do is see if there's any questions on what we did. How are we doing on time? So we're at 8:45. Okay. So what's your question?
Why did you have to see from the side when it wears on you?
What's he talking about? See it from the side? Oh. Okay, so he's asking like why look off to the side? Because your eyes see better that way in the dark. Like don't look directly at it. Look a little bit off. Okay. Why? It hits a part of your eyeball that's good for the dark. Part of your eyeball. Okay, young lady, what do you got?
Can the one that's had like you said the millions of stars, can the stars go behind each other?
Oh yeah, there's stars behind each other, absolutely. Now imagine if you lived on a planet in the globular, how bright the sky would be. Okay, what's your question? Oh, how new comets are made. Okay, the question is how new comets are made. See, I'm learning how to repeat the question for the internet. So, because they just hear, right? So new comets are made. Well, they're not really new. What comets are actually old debris left over from the beginning of the solar system. That's why they're so important. Now we call them new because they got pushed into the inner solar system. So as the Earth goes around, as our solar system goes around our galaxy, as we orbit, it takes about 200 million years to go around once, and nearby stars, their gravity mess up where the comets come from. They push these comets toward the solar system. So they're out there waiting to get pushed into our area of the solar system. So they're old. They're like the most pristine, like original material. So they're really important to get a hold of that stuff to see what the early solar system's like. Yep, go ahead. The what? Oh, the long object? Oumuamua. So, I don't know, about 2 years ago, a very long object, or should say it wasn't very, I think it was like maybe the size of a football field, maybe a little bit longer. There was an object that came in called Oumuamua. It's a Hawaiian name, and it had a width to length ratio 1 to 10, which is really weird. I mean that's like a pencil. Okay, so you know what I mean? Like width is let's say 1 meter, and then length would be 10 meters. But I think it was I think it was around a football field size. Anyways, people are speculating it could be artificial. So it came from another solar system. Okay, it could be that. It could be a spaceship. It could be some weird fragment of something that maybe something broke. So there's different theories out there what it is. I haven't really dug into it, but it's a very strange object. Okay, so I'll dig more into that because that is a very interesting object. So, okay, yep.
How long do comets stay alive?
Wow, that is how long does comets stay alive. It depends on how big they are, how close they get to the sun. Okay, so that's the type of thing. The Geminid meteor shower, which is going to be good in December, that's actually caused by an asteroid, and we think that it might have been, they think that it's associated with this asteroid, and they think that might be a burned out comet. Okay, so like the core of it is left over, and it looks more like an asteroid now. But okay, any other questions? These are great questions.
Yeah, I've never really heard these star clusters before. What makes them different from a galaxy? Like, are they going to turn into one?
Oh, good question. Okay, so there's different types of star clusters. When we talk about star clusters, we're talking about they're in the Milky Way galaxy. So the globular star cluster I showed you, called M13. It's one of the bigger ones. There's one or two that are bigger than that, but it's the best one to observe for the northern hemisphere. But globular star clusters are located, to give you an idea. So picture our galaxy being a wheel. The globulars are located centrally above the wheel, the plane, and below. So they're kind of centered about 20 to 40,000 light years away from the center of the galaxy. Okay. Then there's these things called open star clusters, which like the Pleiades star cluster. Okay. Like you ever see Subaru, their logo? That's the Pleiades star cluster. That's out in the winter. That's what we call an open star cluster. They formed out of a nebula together, and so they hang out together. So it's a smaller object than, let's say, the globs. The globulars are very old, so there's different theories on how galaxies form, and they might play a role in the formation of the galaxy. So, but when we're talking about star clusters, we're always talking in general about our galaxy. They're in our galaxy. Okay. All right. So I think that's it. So go ahead.
If a Bua got close enough for people or NASA to explore, what do people think it would be?
Well, just look it up. People have different theories about it. Unfortunately, it's moving too fast for us to catch up. You know, we didn't really see it. We didn't have that long of an observation. It wasn't like we knew. We only maybe had a year, maybe something like that. It wasn't like a huge amount of time. It's not very big, so we didn't spot it that quickly. So, but it's very weird. I mean, a 1 to 10 ratio. So picture that's almost, it's almost like this shape. What could possibly be that type of shape? You know what I mean? That would be natural. It's really, really odd. So, all right, that's pretty much it. What I'd like to do is Drew, is it dark enough to show constellations?
Oh, yeah.
Because I could bring half of them out to show the constellations and the other half for the telescopes to start it off that way.
Yeah.
So.
Just a second, here we go.
Oh, I'm gonna.
All right, so the moon is still out, and it'll be up for at least probably another hour and a half or
good.
so
So we won't
before
miss
it
that.
gets into our tree horizon. Saturn is already up. Jupiter will be up probably in another half an hour, 40 minutes to get above the tree line. But it's going to be a little hard to see the Milky Way, although if you know what you're looking for, you can sort of see it. So we'll have scopes out in the yard. We'll have our scopes. If you go out the double doors, pardon me, go out the double doors, toward the scopes. If you take a left, go about 30 feet. There's a door to the right. That's our actual observatory. In there are two domes that are open. One on the left, I believe, is looking at the moon. The one on the right is looking at Saturn. But we are also doing the same out in the yard. And so Roy will do some sky tours. And again, you can't leave until you look through a scope.
Right. So I have this